All right, guys, I got my beach hat on, or one of them. This is one of my coaching hats. When I'm out in the sun, I got bigger ones that I'll wear for you guys. So here we go. So today we're going to introduce the unit circle. It's not the only day we're going to do it, so if you're a little confused by the end of it, we will get you guys squared away. We're gonna use it for quite a while, so don't panic if you don't get it right off the bat. So the first thing we're going to talk about is special right triangles. Some of you have seen them already, some of you may have not, and then we're going to talk about special right triangles in the unit circle. So here we go. So we have our first set of special right triangles. These are our special right triangles. All right, so if we're looking at our special right triangles, there are two types. There's the 30, 60, 90 or the 45, 45, 90. You're going to say, well, there's two types, but there's three triangles. That's because this triangle can get twisted and the 60 can become your reference angle. So that's kind of where we've got to kind of tackle it. So there's three different angles we deal with, but there's only two triangles. So if we're dealing with the 30 degree as our reference angle, across from the 30 is 1. That is our opposite side. Adjacent is always equal to root 3. And then our hypotenuse is always equal to 2. So if we're looking here, across from the 30 is 1. Across from the 60 is root 3. Across from the 90 is 2. Now, since we're going to use 60 as the reference angle, this one becomes our opposite. This one becomes our adjacent. And this one is still the hypotenuse. Okay. So we good with that so far? So that's how our they're always that way. It doesn't matter how big the triangle gets. As long as it's a 30, 60, 90, the 30 and the 1 go together, the 60 and the root 3 go together, and the 90 and the 2 go together. So we're dealing with a 45. 45, 45, 90s are a little easier to deal with, so we get 1, 1, and we get root 2. So those don't change much at all. So those are our special right triangles. The sides are always the same. So here we go. So let's look at this one here. We're going to look at the special right triangle at the 30 degree mark. So if I go for the terminal side of 30 degrees here, I know that I have 1, root 3, and 2. And this is 30 degrees, just like this. So what makes it special about the unit circle is that I know that this is going to be cosine and this is going to be sine. And we'll deal with why and how later. So if I'm going to do cosine, it's going to be adjacent over hypotenuse, root 3 over 2. If I'm going to do sine, it's going to be opposite over hypotenuse, 1/2. Cosine and sine always go in this order. So if I move over here to this one, this is 30 degrees. I draw my triangle. I know that this is 2. This is negative root 3 because I moved that way. And this is 1. So if I come over here and I write my coordinate plane and I do, my coordinate, and I do my cosine, and I do my sine. Get this stuff out of the way here, guys. I'm going to do, my cosine is adjacent over hypotenuse, negative root 3 over 2. And then my sine is 1 over 2. Notice something? Same exact values. This is just negative. So if I work my way down here to my horrible circle, because it's not very straight, I know that this is 2 and this is -1 because it went down. So what are my 2 points here? Cosine and sine are going to be, well, you guessed it, √3/2, -√3/2, and my sine is -1/2. Again, 1/2 √3/2, 1/2 √3/2. So let's go to this one here. 1 and 2, but this is a -1 because it's going down. So again, we got cosine and sine. And so I'm going to get my √3/2, √3/2, and then I'm going to get -1/2. So that's how my 30-degree triangles fit on the unit circle. Now there's a lot more that go to it, so let's look at this here. Let's look at this one. Let me erase this out of the way here. So we know, what do we know about the 60? So if I go 60 here, and I draw my 60-degree triangle, and again I go cosine and sine, and I have 60 degrees right here, I'm going to get opposite. Well, we want our cosine first, so my adjacent is 1. My hypotenuse is 2. My sine is √3/2. So if I go to this side and do the same thing, if I match it up, my hypotenuse is 2, across from the 60 is √3, down here is 1. So 1 and √3. So if I do my cosine and sine, I'm going to get cosine 1/2, but it's a negative because it's going that way, -1/2, and my sine will be √3/2. Okay, let's go down here to this 60. So if I go to this 60, this is going to be my adjacent. My hypotenuse is 2, so we're going to move a little faster. Going to match this up. It's -1/2, and it's going to be -√3/2, because the side opposite 60 is always √3. This is why they're special right triangles, because there's patterns to them. And again, this is cosine and this is sine. So now we've got our next one. What's my cosine? My cosine is 1/2 for this. So I've got 1/2 because it went to the right. And then my sine has to do with √3, but it's down, so it's -√3/2. All right. So that's how you deal with 60-degree triangles in the unit circle. All right. So, oops, I don't know why I erased that, but I'll draw it again. So let's look at our 45s. Our 45-degree triangle, since this is 90, that's 45 right there, right in the middle, 45. And we have 1, this should be 1, 1, 1, and √2. So if I look at my cosine and my sine, I'm going to go 1/√2, 1/√2. That means this side has to be the same, because the unit circle is full of patterns. 1/√2, negative, because I went left, -1. That's my cosine. Adjacent over hypotenuse, 1/√2. But if I move down here, I get the same pattern. My cosine is 1 over root 2. My sine is 1, negative 1 over root 2. Look here, and we get 1 and 1 again, and this is root 2. So here's my reference angle, 45 degrees right there. Across from it is 1. That's a negative 1, sorry. So my cosine is adjacent, which is 1. Adjacent is 1 over the hypotenuse is root 2. This triangle, adjacent's negative 1 over root 2. That's my sine. So they start filling in and becoming a repeating pattern. So if you look at all the 45s are the same values, except they just change signs depending on if it's left or right. Now, let's take this, the unit circle. So here's the unit circle. Okay, horrible drawing. There's 4 quadrants: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So now, if I'm just going to take quadrant 1, so I'm just in quadrant 1, guys. And this is my x-axis, and this is my y-axis. And I'm going to draw a 30-degree triangle. And I'm going to ask you, at 30 degrees, what is my sine and my cosine? Well, from the previous, if you look back at your notes, my cosine's always first. My cosine is root 3 over 2. Root 3 over 2, adjacent over hypotenuse. My sine is opposite over hypotenuse. So my sine is 1/2. So there is my coordinate for 30 degrees, or in radians, pi over 6. So two values there. Now I'm going to take the red one and I'm going to draw a 45-degree triangle. And I'm going to put cosine and sine. Cosine, 1 over root 2. Sine, 1 over root 2. And that is for my 45, or if you convert that to radians, it's going to be pi over 4. So now I've got one of them, 2 of them, now I've got my third one. My third one we'll do in purple, and that is going to be the 60. So this is the 45, the red one's the 45. Purple one will be the 60, because it's got a steeper curve. So this is the 60. And again, it's cosine and sine. So what do we got? Well, cosine adjacent, because remember we're dealing with 60, adjacent is 1/2 over hypotenuse, and then my sine is opposite over hypotenuse. This is quadrant 1. So what I want you, and this is for 60 degrees, or pi over 3. So it goes pi over 6, pi over 4, pi over 3, which is the same as 30 degrees, 45 degrees, or 60 degrees. These are the coordinate pair. These are x and y. Okay? So right now I really only want you guys to focus on quadrant 1. You'll run into other types of problems that may take you out of quadrant 1, but I'm going to stop. Actually, let's see here. Let's do quadrant 2. So now we're on the second half of the circle. Go over here. Quadrant 2 now. And I'm just going to draw my 30, my 45, and my 60. Okay, so here we go. This is 30 degrees. This is 180 degrees. So this has to be 150 degrees right here. That's 150 degrees, which is the same as 5 pi over 6. Let's look at its sine and cosine. Sine and cosine are going to be exactly the same. Root 3 over 2 and 1/2. Because it's a 30 degree. Now the key is, this is x. X is moving left, so that has to be negative. It's a negative x. And this is y. Y is positive. So if I go up to here, and we go 135, or 3 pi over 4. Here's my 45 right here. Take my same values. 1 square root of 2, 1 square root of 2. Since my x value is on the left of the y-axis, remember this is the y-axis, since it's to the left, it means my x has to be negative. So that's my answers there. This is the last one for the day. We're going to take our values from the 60, from the first quadrant, we're going to put them here. And we're going to take that. To the left is x, and so that means this is going to be negative 1/2. And this is cosine and sine, always. Cosine and sine, x and y. So look at your pattern here, guys. 3, root 3, root 2, 1. Root 3, root 2, 1. There's always a specific pattern. So if you guys can kind of start seeing the pattern, it will be very beneficial to you guys gradually learning this. We're going to keep working with this. I'm going to introduce more on Monday. So just stay with it. Remember, it's based on the 3 special right triangles. And we shall see you on Monday.